Hey guys, this is Miss Mo. We are jumping to 9.4, 5, and 6, and 9, 4, 5, and 6 is a lot like 3.4, adding and subtracting all kinds of fractions. The only thing is, now our answers can be negative. So far, every single number you've typed in your homework has been positive, but now they could be negative. Ooh, okay, so, first let's go over how to add positives and negatives. Okay, first off, if both signs are positive, then you just add them and you keep a positive as your answer. So, like positive 4 plus 8 is 12, or positive 3 plus 1 is positive 4, and you don't have to put the positive on it. I'm just doing it for now. Okay, so, but I think we already know that. So 2 positives add up to always a positive. This is the one that people forget about every day of their life. 2 negatives add up to a negative. So if you look at this, 4 plus 8 equals 12. And then if you look at this, negative 4 plus negative 8 equals negative 12. You see that they're both equal to 12s. And it's because when you have the same symbol, you add them in your head and you keep the sign. So if you have 2 negatives, you add them just like as if they were positives. You add them. And then you keep the sign of whatever you had. So for example, negative 3 plus negative 1. They're both negatives. So you add them in your face. 3 plus 1, 4. But then you tack on the negative. Negative. Okay, try another one. What about negative 2 minus 5? Okay, that looks like I'm not adding, but check out the symbols. They're both a negative or a minus. So technically, since these are both minuses or both negatives, you're going to add them in your face. 7. Keep the symbol negative. Try another one. What about negative 20 minus 100? Yes, this might look like a subtraction problem, but when you grow up and you go to when we grow up, whatever, in a couple of semesters when we're in college algebra, if you see 2 minuses, that means you add them in your face, 120, and you keep the negative, negative 120. Okay, so notice that you don't always have to have this plus sign in between. Sometimes it's just a straight negative and then a minus a number, and that minus a number, we're considering it as a negative. Okay, now let's say if both signs are different. This is what gets people. Whenever the signs are different, you subtract them in your face. And then attach the symbol of the bigger guy. And I'll explain what I mean. Okay, so when your signs are different, like say we have 8 and a negative 4. This 8 is a positive, that 4 is negative. Okay, you subtract them in your face. 8 minus 4. 4. So that's the subtracting it in your face. Then you attach the symbol of the big guy. Okay, well, who was bigger here? The number 8, the first number, or the second? Just look at the digit. Just look at the actual number 4. Which one's bigger, this 8 or this 4? Well, the 8 is bigger. So we're going to attach a positive to our answer. That's why our answer is 4, or positive 4. Okay, let's do it again. This sucker. -8 plus 4, those are different symbols, but you subtract them in your head. 8 minus 4 is 4. But then the bigger number out of 8 and 4 is this -8, or the 8 is bigger. So you're going to keep the sign of the negative. What? Try again. Let's say we have 17 plus -3. Okay, let's see what symbols they are. I have a positive 17, and a -3. Okay, so they're different symbols. So subtract them in your face. 17 minus 3 is 14. Attach the symbol of the bigger guy. Well, out of 17 and 3, 17's bigger, and he's positive. So positive 14. Let's try another one. Let's try -3 plus 2. Well, they're different symbols, so you subtract them in your head. 3 minus 2 is 1. But then you tack on the symbol of the bigger number. What's bigger, 3 or 2? 3. So you attach the negative from it. Whoa. Okay, try another one. Let's say 8 plus a -4, -5. They're different symbols because the 5 is negative, the 8 is positive. So you subtract them in your head, 3. Then you tack on the symbol from the bigger number. Positive. Yay. Okay, let's keep going. All right, 9, 4 might have some easy math like this, but then it also has crazy fractions, so let's focus on the fractions. Okay, first, before we do anything, we have to do Texas to get these fractions away from a mixed number. Okay, so if I do Texas, this 23 over 6 is the same. Then for the Texas, 3 times 10 is 30, plus 3 is 33 over 10. Okay, now think of the denominators. I have a 6 and a 10. What are the multiples? 6, 12, 18, yada, yada, yada. I think I'm going to wind up at 30 because the multiples of 10 are 10, 20, 30. Okay, so my LCD is 30. How do we get to a 30? Well, for this 6, we're going to multiply by 5, top and bottom. For this 10, we're going to multiply by 3 to get a 30. Okay, let's see what you get. Left to right. Now that we are out of that test 1, we can use our calculator. So the first sucker is 115 over 30, plus the second sucker is 99 over 30. We add it and we get 214 over 30. Okay, you should be able to reduce though. I know we can reduce by 2. Let's try that. If I reduce it by 2, we get 107 over 15. And then, yeah, I think that's as far as we can go. Okay, so the part where we used what we just learned is when we saw that we had a plusative 99 and then there was a plusative 115, and that came out to be when you have two plusatives, you add them and keep them positive. So that's why I added them and kept it at positive 214. Okay, if you want a mixed number, you have to do the division. You have to say 15 goes into 107. 7 times. That was super lucky. With a remainder of 2. So this is 107 over 15, or 15, nope, or the big old number from the top of the house, 7, and then a fraction bar with the remainder, 2, over what you divided by, 15. Woo! See how it's repetitive of what we have done? Okay, let's look at the page on the back, because that's where all the minuses are. Okay, let's look at this 7 over 8 minus 2 over 12. Think about the multiplication facts of 8 and 12. What is the lowest in common? And it should be 24. So now how do we get to 24? Well, on the left, we have to multiply by 3. On the right, to get 24 in the bottom, we're trying to get 24 in the bottom. On the right, you have to multiply 12 by 2. Okay, so let's go ahead and multiply these. Remember, we multiply left to right. So we get 21 over 24 minus 4 over 24. Okay, this is where we use what we just learned. I have a positive 21 and I have a minus 4 or a negative 4. So in college algebra, this 4 over 24 is considered both minus 24 and, or minus 4 over 24 and negative 4 over 24. Okay, so let's think about this. Positive 21 minus 4. That means the symbols are different, so you subtract them in your head, 17. But you have to keep the symbol of the biggest number. What's bigger, 4 or 21? It's 21. So my answer is a positive 17 over 24. And then I don't think you can reduce, so that one's done. Okay, why don't we skip down below to this 5 over 6 sucker? Okay, let's think of my LCD. Think of 6s and 4s. What is the lowest common multiplication fact of 6 and 4? It should be 24 again. Awkward. Okay, now let's get our denominators up to a 24. On the left, we have to multiply by 4. On the right, we have to multiply by 6s. And let's see what we get. Don't forget, multiply left to right. 4 times 5 is 20 over 24 minus 3 times 6 is 18 over 24. Okay, let's think about the symbols on here. This 20 is a plusative, and this 18 is technically a negative. Okay, so we have a plusative and a minus. When you have two different symbols, you subtract them in your face. 20 minus 18 is subtract them in your face, 6. Then write the symbol of the bigger number. What's bigger, 18 or 20? Well, the 20. So since 20 is positive, I'm going to put a positive 6 on top. All over 24. And then I think you can reduce that to like 1 over 4. Hot sauce. All right. Let's keep going. How about we try this 20 over 8 minus 12 over 10. 20 over 8 minus 12 over 10. Okay, first we're going to think of all the multiplication facts of 8. And then we're going to do the same thing for 10. And you might think that 80 is the common multiplication fact, and it is, but it's not the lowest. 40 is the lowest common multiplication fact. Okay, so how do we get from an 8 in the bottom to a 40? We multiply by 5s. How do we get from a 10 in the bottom to a 40? We multiply by 4s. Okay, this becomes 5 times 20. 100 over 8 minus 48 over 8. Okay, let's see. When we subtract numbers, this 100 is a positive, this 48 is a minus. When you have different symbols, you subtract them in your face. 52. Then you attach the symbol of whatever the bigger number is. What's bigger, 48 or 100? 100. So we're going to attach a positive. And then it's all over 8. And then I think you can reduce by 4 maybe? I know you can reduce by 2, but I think you can also reduce by 4. If you reduce by 4, I think it's 26, 13 over 2. And remember, if you want that as a mixed number, you throw it in a division house. 2 can go into 13 6 times to make 12, and there's 1 left over. So my mixed number is a big old fat 6, and then a fraction bar of remainder 1 over what we divided by, 2. Woo! Okay, let's try another one. Let's try this one right below it. Okay, first we're gonna think about our multiplication facts. Actually, first, look, there's this darn mixed number. We gotta do Texas first. Poop. Okay, let's do Texas. 4 times 1, 4, plus 1, 5. So this is 5 over 4 minus 12 over 10. Okay, let's think about the multiplication facts. What is the smallest common number from 4 and 10 when you think about your multiplication facts? And it should be 40. So let's multiply by what we need to get 40. On the left, it's some 10s. On the right, it's some 4s. All right, and we get 50 over 40 minus 48 over 40. And the 40 stays on the bottom. On the top, 50 minus 48, those are opposite symbols, so you go ahead and subtract in your face. And is it plusative or negative? Well, the 50 was plusative, the 48 was technically a negative, so the bigger number is a plusative, so my answer is going to be plusative. And then I think you can reduce it by 2, so it pops out 1 over 20. And then that is not a mixed number because it's not top heavy. Okay, so let's just review real quick again how to add numbers and subtract numbers. Let's say we have 24, negative 24 plus 13. Those are different symbols. We have a negative and a plus. Since those are different symbols, you subtract them in your face. And we get 11. But then you tack on the symbol from the bigger number. What's bigger? Don't look at the minus or the plus. Just look at the 24 and the 13. Which one's bigger? The 24 is. So you keep a negative on your answer. Okay, let's try another one. How about we have 14 plus a negative 5. Okay, well, the 5 is negative. You can't tell, but the 14 is positive. So they're different symbols. So let's subtract them in our head. 14 minus 5, 9. Then you keep the symbol of whatever is bigger. So what's bigger, 14 or 5? Well, the 14 is. What is the 14? The 14 is plusative. So my answer is plusative 9. Okay. Woohoo! Let's look into 9.6. So everything we've just covered is 9.4 and 5. Again, it's all about those symbols. Whatever is the biggest when you're not looking at the symbols, that's what symbol you use. So let's say I had 16 minus 16 plus a negative 11. Those are different symbols. 16 is a positive, 11 is a negative. So you subtract them in your face, 5. Keep the symbol of the bigger number. 16 is bigger than 11, so we're gonna keep a positive. Yay. Okay, so that's 9 point, what was it? 4 and 9.5. In 9.6, we multiply and divide things. Okay, multiplication and division rules are different than plussing and minusing. Okay, so these rules over here, they're for multiplying and dividing. Okay, if you look, positive times a positive is a positive, okay? Negative times a negative is still a positive. But then if you have different symbols, that's when it always pops out negative, negative. So that's different, because when we added and subtracted different symbols, sometimes we got a negative, sometimes we got a positive. But when you multiply and divide different symbols, you always get negative. What? So when you multiply and divide different symbols, you always get a negative. When you add and subtract different symbols, you could get either one. Okay, so anyway, let's see here. Let's look at this. 5 over 1 times 2 over 4. Okay, well, positive 5 times positive 1, it's still 5. Positive 2 over positive 4 is still 8. And remember, we multiply left to right. So 5 over 8. Let's look at this one below it. First, we have to do Texas. Okay. So 3 times 3, 9, plus 1, 10 over 3. Times Texas. 2 times 3, 6, plus 1, 7 over 2. Then how do we multiply? Left to right. So we get 70 over 6. And is it a positive or a negative? Well, we have two positives multiplying together, so they equal up a positive number. Okay, with that 70 and 6, I think we can reduce maybe by a 2. And I think we get 35 over 3. And if we want the mixed number, 3 goes into 3 once, 3 goes into 5 once, with 2 left over. So this is 35 over 3, or 11, and the fraction bar with your remainder on top and what you divided by on bottom. Okay, let's try this next sucker, but on this next one, let's put a negative on it. How about we have a negative 3 2/4 times a positive 10 over 4, and let's see what happens. Okay, so let's change this up to have negative 3 2/4 times 10/4. Okay, the first thing we have to do is Texas. And when we do Texas, we don't worry about that negative. We just look at the regular numbers. 4 times 3, 12, plus 2, 14 over 3. And keep a minus. So when we do Texas, we don't actually do 4 multiply negative 3. We just deal with 4 times 3, then add 2, then tack on the negative. Okay, let's look at this sucker. We're timesing by 10 over 4. Okay, how do we multiply? We multiply left to right. Okay, So negative 14 times 10 is, let's see, that 14 is a negative. What symbol is that 10? Well, it's sure not a negative 10 because I would see a negative symbol. So that 10 must be a plusative. Okay, well, negative times a plusative is, negative times a plusative is always a negative. So this spits out negative 140 all over 12. And then I think you can reduce this. Let's try by 4. I think you can reduce it by 4. And you get a 3 on the bottom. And 2, 5 on top. Negative 25. I think, right? Let me see here. Oh, 35. My bad. Negative 35. Okay. Now let's try and turn it into a mixed number. So this is negative 35 over 3. Or if you want to change it into a mixed number, how many times does 3 go into 35? Definitely 10 times. Definitely. Oh, we already did it. It's up here. Yeah. 11 and 2/3. Negative 11 and 2/3. Woohoo! So, a negative times a positive always spits out a negative, no matter what. Okay, let's work with some keep, change, flip. Okay, over here we have 1/5 divided by 2/3. Anytime we divide with fractions, we have to do keep, change, flip. Okay, so we're gonna keep that 1/2. We're gonna change the divide dot to a multiply dot, and then we flip that fraction upside down. Now we multiply left to right, and we get 3 over 10. Okay, and what kind of symbol is it? Well, the 1 on top was positive. The 3 on top is positive, so they should multiply to a positive. And then this is not a mixed number because the top is not bigger than the bottom. All right, let's do another one. Let's try this sucker. Before we can keep, change, flip, we have to do Texas. So let's see what we get. 7 times 2, 14, plus 1, 15 over 2, divided by 21 over 4. Now let's do keep, change, flip. So let's do keep, change, flip. So 15 over 2, multiply dot, 4 over 21. And we can either reduce at the end or now. Let's try reducing now. Remember, when it comes to fractions, you can cancel up and down diagonally. Yep, okay. Well, let's see. Can I reduce up and down? 15 over 2? Nope. Hey, but this 2 and 4, I can reduce those by 2. Okay, well, 4 divided by 2 is 2. The 2 on the bottom divided by 2 is 1. I think I can reduce this 15 and 21 also, because those are diagonal. You can divide them by 3. 15 divided by 3 is 5. 21 divided by 3 is 7. Okay, so I just reduced ahead of time, and let's see what fractions we have now. Now we have 5 over 1. Multiply dot, 2 over 7. All right, multiply left to right. 10 over 7. Or, what is that as a mixed number? 7 divides into 10 once, with 3 left over, and the 7 on the bottom. Woo! Okay, so from these sections, what you need to remember is if you are adding and subtracting, Then you add in your face. Okay. Then you attach the symbol of the bigger. So, for example, negative 23 plus 50. You subtract them in your face. 50 minus 23, I think, is like a 17. And then you keep the symbol of the bigger number without the symbols. Okay, so if you're not looking at these symbols, which number is bigger, 23 or 50? It's the 50. So you're going to keep a positive on your answer. Whereas if it were backwards, let's say +23 minus 50. Those are different symbols. One's a plus, one's a minus. So you subtract them in your head, 17. Then, which number is bigger if you're not looking at the symbols? Well, the 50 is. So you're going to attach the minus on it from that 50. So again, whatever is bigger, you keep that symbol. Whereas when you're multiplying and dividing, different symbols multiply up to a negative. Same symbols multiply up to a positive. So those are the tricky rules. It's pretty much this attaching the symbol of the bigger number that's going to get you messed up in college algebra.